So this is the third video in our series on displaying video on the Commander X16. So far we have chosen our source video, we recorded it, and we have converted the images into 160 by 68 pixel images, 256 color bitmaps. So there's 2,866 of these, one each for every frame. At 20 frames per second, that's 2 minutes 23.3 seconds of video. We've also taken the audio file, converted it into, we've taken this raw audio file, we've converted it into 12,970 hertz raw PCM audio data. It's 16-bit in stereo, and that's stored in this audio file, and we have converted that into 2,866 files, each 2,594 bytes long. So now, in our last video, we went through our bitmap, our tile map rather. We have our tile map here, and we converted that tile map into something on a spreadsheet. We also created a low byte and high byte offset for each column and an address for each row, a low byte and high byte. We can add those together, so for every row and every column we can look up these two values, add them together, come up with an address in memory. All these data statements are automatically generated, so these first 2,048 bytes in these data statements, whoops, way too far. These are the tile map data, and then the remaining 512 bytes are the two lookup tables we generated the last time. So now what we can do is actually start programming. We can take this little basic program, Control C to copy it, I can close that out. And now back on the Commander X16, I'm just going to reset and paste. Control R, Control V. And that loads up the basic program that we wrote in the spreadsheet. And when we run it, if it says -1, then it successfully loaded all of that. I'm going to just list to 999. And this is the basic program that loaded that. You can see it's stored all of that starting at hex value 7000. So now that's good. Next thing we're going to do is load up the editor. This is the Metal assembly language editor. And if we list that, you can see my blonde moment when I wrote the editor. I should have done this differently. And so we're just going to change this right now. This basic bootstrap is way too long. We're going to write a new one. There, that does the same thing, but now it's much shorter. And now when we run it, it loads up the editor. And if I go to basic and hit F5, now we can see our new basic program. We have 0B08 is our link, 0100 is our line number, 9E is the basic token for sys, 1024 self-explanatory, 0 is the end of line, 080B was our last link, and our new link is 00, that's the end of the program. 080D is now our first byte. So F1, we'll just put a label in here, a temporary label for right now. Okay, so if we go to 7000, this is where we've stored that data that we had in all those data statements. So you can see that there's a whole bunch of zeros. That's all those tile zeros at the top of our screen. And then we've got 20 tiles and then 12 blank tiles, 20 tiles, 12 blank tiles, as we expected. So if we'll just zip through all of this, 7071, so 273, that's the top of the screen. When we get to 74, now this is the bottom screen. So if I just bring up our tile map here, 74, this is the start of the second screen. And I'll just scroll down through this. Now we can see the tiles that are stored there. You can see that the second byte here is 1. If we go back up to further up, you can see that the second byte was 0. So that's the only difference between the top screen and the bottom screen. So at the end of this, at 7800, this here is the start of the two lookup tables. This is for the columns right here. This is the low byte of the columns. And down here is the start of the high byte, rather the low byte for the rows. Got to get that right. And down here, this is the high byte for the column, the high byte offset. And right here, this is the high byte of the row address. So we're going to be moving that. If we look at our memory maps here, let's bring up the low RAM memory map. We're going to be moving those two lookup tables that are currently at 7800 and 7900. We're going to be moving those down to 0900 and 0A00. But before we do that, oh, and we're also going to be saving the tile map, which is currently located right now 7000 to 77FF. We're going to save that. But before we do all of that, let's go back. So temp here, all of this from 080D onto 6FFF is all garbage. It's all, if I hit F5 right now, you can see it's all that basic code that we just pasted into here from the spreadsheet. So we want to get rid of all of that. So we're going to write a short piece of assembly language code just to set all of this to 0. I'm going to first of all go into 0 page. And I'm going to set a couple labels here. TMP1, TMP2, and in here I'm going to set a 0 in TMP1, and I'm going to load A with the value 8 and store that in 0 page at TMP2. So now TMP1 is 0 and TMP2 is 8. So that's pointing to page, that's pointing to memory address 0800. So we're going to load Y with some offset value. Right, I don't know what it's going to be right now, so I'm just going to choose, some offset value at random. We're just going to pick 1D for now. And what we're going to do is we're going to load the accumulator with 0. We're going to store that. Okay, we're going to store that in an address that is indirect indexed 0 page comma Y. And on the metal editor, that's, instead of writing all that down, you just type minus. So now whatever address is pointed to by TMP1, TMP2, we add Y to that address, and that address then will get a 0 stored there. And then we will increment Y, and as long as Y is not equal to 0, we're going to branch to 0817. And if Y is equal to 0, we're going to increment the 0 page address there. Okay, so that increments the high byte. And we load A with whatever is stored there, and we will compare it to 70. So once we reach 7000, we stop. If it's not equal to that though, whoops, we're going to branch to the address 0815. Okay, and at that point we're done. Okay, so now we know we want to start at 0825, so at this point y has to contain the value 25. Okay, so we'll execute temp. Okay, so now everything from 0825 to 6FFF is 0. So I got rid of all of that garbage, but still kept all of our data for our tile map and for the data tables that we want to move down to page 9 and page A. So we no longer need temp, so I'm just going to set a new label here. I'm going to call it start, because eventually what's going to happen is we're going to change this basic program eventually. It's going to say, instead of 1024, which is pointing to the start of the editor, we're going to have it jump to 2061, which is this address here at start. And later on, this is going to jump to wherever we actually have the start of our assembly language code, our main program. And for now, we'll just have it point at the editor. Okay, so from this point on, now we've got space for strings. So I'm going to set another label here. We've got several file names that we're going to have. First of all, we're going to have, for every frame of the video, we're going to have a palette, we're going to have an audio file, and we're going to have the video image file. We're also going to have a tile map file that we're going to well, we've got it in memory now, we've got to save it, and we're going to have to load that up into Vera later on. We're also going to have a file a file name for the source bitmap file, because we're going to do the conversion of the bitmap files here in assembly language. So that's 5 file names right off the bat. So let's set our first file name. This is going to be the source bitmap file. So we'll call this string here S file. This is going to be our file name for the source bitmap file, and we know that those source bitmap files are located here. So our path is swars raw C256, and then the file name is image0001.bmp for the first one. So we go SWARS raw C256 image0001.bmp. Okay, make sure I've got that right. I do. I know this is 27 characters long, so I just go F1 and STRI1B. Okay. I go F5 again and just go up 3 characters. You can see that's the last 3 characters of that string. F1. Okay. We're going to set another string here. This is going to be our tile map file name. And we'll just repeat that process. I'm going to pause here while I set up all these file names. Okay, so I have entered all of those other file names in there. And now I'm just going to add some comments here. And I'll pause here while I add some more comments. So with that done, now there's a couple of little subroutines that I want to copy out of Golden Ram, out of the editor itself. I find it's very helpful to do these little subroutines that I know I'm going to need first and get them out of the way, and then later on, as I get into the more complicated parts of the program, that it just amounts to strings of subroutine calls. First of all, though, there is one string that is in Golden Ram that I want to copy here into Low Ram, because eventually I want to just have this be a standalone program that won't have the editor attached to it. So I'm going to take everything that I need out of the editor and just copy it in. So if we go to hex D, this is in Golden Ram, you can see it's just a string of 16 characters, the pesky characters that correspond to the hex digits. So what I'm going to do is copy these into Low Ram as well. And we're going to do that just like that, and we'll set a label here, C hex, call it a string, and that's our hex digits. And the other subroutine I want to copy out of Low Ram is S181. Now there's two subroutines here. S181 sets the logical first and second to 1, 8, and 1. S180 sets the logical first and second to 1, 8, and 0. So you call S180 when you want to open a channel for loading, and S181 when you want to load a channel for saving. So we're going to go back and we'll copy S181 to 0879, 13 characters, set a label here. Okay, so we've got something good so far here. Now we also want to copy our lookup tables from 7800 to 0900. So and we want to copy from 7900 to 0A00. Set our file in there. We'll go to strt, and now we can save. Okay, so right now we have a file that starts at 0400 and goes to 0B00, or rather 0AFF, that we have saved. That's everything that you see on the screen right now, plus the little basic bootstrap program, and also it's got the two lookup tables. So at this point, now all we have to do is save those save that tile map, which is stored at 7000. So that's our next thing. What we have to do is we want to set the file name to be the file name of our tile map. So I'm going to set a label here. It's going to be TFNM. We'll comment this. Set tile map file name. Okay, so we load X with the low byte of our file name. We load Y with the high byte of our file name. Oops. And we load A with the length of our file name. And then we jump to the kernel subroutine snam. So if we want to save the tile map, What we're going to do then is we need to set two zero-page locations with the start of our tile map. So let's go to TMP1. We'll use TMP1 and TMP2 as our locations. So we set TMP1 to 0, and we're going to set TMP2 to 70. Okay. And next we're going to set X and Y with the low byte and high byte of the first byte after the end of our tile map file. So X is 0 and 78. Okay, so I've forgotten a couple of things here. So I'm just going to set the file end right there. I've forgotten I have to insert a couple of things. 6 bytes. Okay, so we have to jump to the subroutine first of all, SSSS, and then we have to jump to the subroutine TFNM, and now we can set TMP1 to 0. Okay, so calling SSSS sets 1, 8, and 1 in our logical first and second. TFNM sets our tile map file name. Setting this here to 7000, that sets the start of our file name. 0078 is the end of our file name plus 1. Now we load A with TMP1's location and we jump to save. Okay, good. So now if we execute smap and we look in our files here, up in swars, and there it is, tile map. We just saved tile map. So I'll go back here to this. We'll go to 0900, and if I hit F3, you can see that this is indeed the lookup tables that we had before. And we've saved our tile map. So let's go to 0B00 one more time. Set our file end here. And we'll save what we've got. And that's good enough for this video. We'll do some more programming in the next video. But at least we've got our tile map saved and we've got our lookup tables saved.